I thought I'd start with some of the policy drivers for why we should consider biodiversity in SuDS. And I've highlighted a couple of important ones here. The National Planning Policy Framework introduces for the first time, I think, into the planning system the concept of ecosystem services and the wider benefits that come from that. And SuDS is a really good example of ecosystem services in practice. So it's using natural processes to manage floodwater, to improve water quality, to enhance biodiversity, for example. And then the Natural Environment White Paper from 2011, this builds very much on this, and it talks about ecosystem services, it talks about green infrastructure and provides some very helpful guidance on how SuDS can be an integral part of green infrastructure. And it specifically mentions SuDS, and it talks in terms of things like SuDS mimicking the natural environment, and SuDS being used to create habitats. The Making Space for Nature report, some of you may be aware of, sometimes called the Lawton report, talks about creating more resilient ecological networks, and again, SuDS play an important role, or can play an important role in this. And the Biodiversity Strategy, England's Biodiversity Strategy this is, Biodiversity 2020, again talks about SuDS and bringing SuDS into ecological networks, and also focusing on this idea of multifunctional development, so you're getting maximum use out of the same area of land in the development and planning process. So those are some of the reasons why we ought to be doing biodiversity in SuDS. And in my next slide, I thought I'd share my experience of why a lot of the developers that we work with actually want to do biodiversity in SuDS. And one of the most important messages is that they very firmly recognise that well-designed SuDS can contribute to high-quality design. There's some really excellent guidance by CABE about access to natural green space and access to green networks through the planning system. We've heard it a number of times already, but developers do recognise multiple benefits associated with SuDS. They represent good value for money because you can deal with surface water, you can deal with water quality issues, you can enhance biodiversity all in one place. The biodiversity mitigation thing is interesting. I've worked on a number of schemes whereby SuDS are seen as a really important mechanism for actually mitigating for habitat loss elsewhere on the site. But I put a word of caution up here that SuDS will not generally be accepted as a means of mitigating for impacts on great crested newts. So you'd be expected to provide additional ponds if you're having impacts on great crested newts. You can't just pop them in your SuDS. From a biodiversity perspective, SuDS can also be a really important buffer zone, for example, adjacent to a sensitive site or to safeguard protected species. And this ability to integrate with public open space and integrate with access provision, pedestrian walkways and such like, is a really important feature of the site. And very importantly, and I'll show you a nice slide later on, an example where a well-designed SuDS has actually been used to increase the property value of those dwellings which overlook it. So making it happen in practice, you've probably heard it a million times before, but it's really, really important. Biodiversity does have to be considered at a very early stage in the design process. And the examples I'm going to show are very much about built development and planning. So very often there'll be a master planning stage, and it's really important that the SuDS design and the biodiversity enhancements that go with that are embedded in the master planning from the outset. And this of course should be underpinned by a robust survey. And the reason why it's so important to fix SuDS into master planning at an early stage is to get the location right. And we want to think about things like strategic positioning of SuDS, so that they link into existing areas of habitat that are going to be retained on the site, and to provide things like stepping zones, wildlife corridors, etc. for the movement of wildlife. And another benefit of incorporating SuDS at the master planning stage is that so it can be linked into areas of existing habitat value that are going to be retained. So once we've got the location fixed at the master planning stage, it's relatively easy then to tweak the design. Much easier to do that than to try and retrofit biodiversity onto a SuDS scheme that's fundamentally in the wrong place. The concept design stage is really the fun bit, and it involves a lot of teamwork, usually between the drainage engineer, A landscape architect will often be involved, there'll be an ecologist, there might be water quality issues to address, there might be input required from a contaminated land specialist, for example. And it's at this stage that the key principles of the design are established, so things like understanding how the hydrograph will function, we'll be looking at things like the size and the shape and the profile and the cross-sections of the SuDS to incorporate biodiversity. And you might want to think about things like other protected species, so you might have a target to enhance habitat for water vole or birds or invertebrates. And very importantly, and I'll come back to this later because it's a key consideration, is selecting the right plant species or assemblages of species that are suited to the hydrological conditions and pollution levels, etc. And very importantly as well, at this very early stage, we do need to think about management. It's a very thorny issue, and you will have often heard quoted that SuDS are expensive and complicated to manage. It doesn't necessarily have to be that way, but only if you think about management from the outset. Once you've got your concept design in place, then the next stage is to consult, and you'll often do that at a much earlier stage, of course, to make sure you've got the Environment Agency, local planning authority, ecologists on board, for example. And often at the moment, my experience is that the detailed design of SuDS will be secured through planning conditions. And I guess we're also waiting to see how the latest government consultation pans out and how delivery of SuDS will be secured through planning in due course. But at some point, there'll be a need to turn your concept design into sort of as-built specifications. Once approved, we go into the construction stage, and I've mentioned here that there'll often be a sort of element of ecological supervision. The amount of ecological input is variable according to the complexity. So the kind of examples I'm going to show you are at the more complex wetland habitat creation end of the scale. So you wouldn't necessarily need this level of input if you were designing and building a swale, for example. The construction might be guided by method statements. Very often it will form part of a construction environment management plan that takes on board other environmental considerations like dealing with the waste arising from the construction of the wetland, safeguarding water quality downstream, for example. Very often the SuDS, or certainly the examples we've been involved in, are an integral part of areas that have already got quite a lot of ecological value. So there needs to be quite a lot of thought and effort going into safeguarding water quality, fisheries interests, protected species, nesting birds, that kind of thing. And then we come on to the management stage, and typically for these more complex habitats or wetland type SuDS, there might be something like a 5-year establishment phase, and during that period it's a good idea to monitor and respond quite quickly to any issues, so failure of plant species to establish, problems arising from scour or erosion, algae growth, for example. And then in the longer term, it can be a good idea to produce a long-term management plan, and that can often be linked in, for example, if the SuDS is integral to an area of public open space or green infrastructure, that can all be tied in together and consider amenity and landscape requirements alongside biodiversity. Again, for the more complex schemes, it's often a good idea to build in some form of ecological monitoring to assess how the SuDS is functioning in terms of its biodiversity value. And this will often be an absolute requirement if, for example, your SuDS is intended to act as mitigation for the loss of habitats or impacts on protected species elsewhere. The example I put up here, interestingly named, I'm not quite sure why, Pity Me Cars SuDS scheme. We worked in partnership with the local wildlife trust there, who allowed the SuDS for the development scheme to be created on an adjacent nature reserve, provided that we could guarantee that water quality wouldn't be a problem. And then in terms of long-term management, we worked with the wildlife trust. They built in the management of the SuDS scheme as part of their nature reserve management, and it was all tied up in the management plan in agreement with them. So just coming back to some of the really important design considerations to make sure that we get biodiversity right, because it's quite easy to get right, but it's also quite easy to get it horribly wrong. And some of the really important considerations, I've just bullet pointed here. You need to identify what your target habitat types are and design them in. Don't just expect them to appear by magic. You need to think very carefully about what plant species you're going to introduce into the SuDS to make sure that they establish and that they survive in the long term and that they do what they're supposed to, that they perform from a technical point of view. And I've mentioned it before, but we need to consider very carefully management requirements. I mentioned at the beginning, our experience is that management can be very straightforward if it's considered from the outset. And quite often you'll just be looking at a 20-year cycle of vegetation management. It doesn't necessarily need to be more complicated than that. In terms of achieving the habitat diversity that we're after, this slide beautifully illustrates the range of different habitat niches that we might be looking for in a complex wetlands type of SuDS system. So we've got open water, we've got floating vegetation, we've got marginal vegetation, and we've got this fringe of trees and scrub. So that's your sort of ideal. Whoops, apologies. And hopefully you can, yes, you can read it. This slide illustrates a cross-section through quite a simple little SuDS scheme that we designed recently at Rolleston Cricket Club to deal with surface water in Staffordshire. And we've managed to incorporate 3 or 4 different habitat types. We've got dry grassland on the slopes, we've got a reed bed on the shallow ledge, we've got areas of open water, and we've got willow scrub on a little island, all achieved by selecting appropriate depths and gradients to support these different vegetation types. Selecting suitable plant species. This is one of the most important jobs of the ecologist, to advise on the correct things to grow that will suit the conditions. And it's an area, as I say, that can go horribly wrong if, for example, you select species that are too aggressive, they will completely take over and you'll lose the diversity that you're aiming to achieve. Or they might not perform if, for example, what's driving your SuDS design is treatment of water quality. You might be focusing very much on reeds. Unless you get the water depth right, the reeds won't thrive and the system won't function. So firstly, we need to look very carefully at the hydrological conditions. So we might look at the sort of graphs that Anthony had up on the screen earlier. We'll be looking at things like time, depth, duration of flooding, and match the selection of species very closely to this. So we might look at species, for example, that are tolerant of both drought conditions and also extended periods of inundation, and that can tolerate and survive both. A really good source of information on selection of the correct plant species is a publication some of you may have come across. It's a little bit dated now, but Wheeler from 2004, and it's called Eco-Hydrological Guidelines for Lowland Wetland Plant Species. It's a really helpful reference document, and it lists a whole range of different wetland plant species, locally appropriate native species, and their precise hydrological requirements. So we use this as a key reference. And the final point I've included on that slide there is about selecting plant species and vegetation assemblages that are appropriate to the locality. And this is less to do with their ability to survive in the particular hydrological conditions or have the right pollution tolerance, but it's more to do with being appropriate to their locality. They should be native, ideally, although that's not always the case. And they need to provide the right sort of ecological linkage and stepping stones for species in the wider area to colonise the site. And it's important as well to think about how the SuDS is going to be used, and if it's integrated into areas of public open space, for example. You might want to use species that are more visually attractive. If it's tucked away in the corner of an industrial area where it's not going to be seen by anybody, then use of single species reeds, for example, might be more appropriate. So in the next few slides, I was going to illustrate some of the case studies that we've been involved in designing and building over the last few years. This is going back to Rolleston, so just to illustrate over a very small area how we've managed to incorporate 4 very different habitat types into quite a small area. A more complex design is this one in Framwellgate. This is up in County Durham, And this is a more detailed scheme, so it's taken it a little bit further than this concept design stage and is almost as built. So we've got detailed specifications for things like water depth, substrate type. We've got detailed specifications for the planting mix, both in the wetland areas and around the banks of the SuDS as well. This particular example was on quite acidic substrate, so rather than go for a sort of wildflower mix, we've used an acidic grassland mix and tried to establish heather on the banks of this particular SuDS. Unfortunately, I haven't got a photograph of this one as it is now. We've not been back recently. It'll be very interesting to see how this one's developed. Some other case studies. This example, Mayfield Farm, is at Heathrow Airport, and it's quite close to one of the runways at Heathrow. And this was a SuDS scheme that was led very much by water quality issues. It was designed to treat water contaminated with deicant, which comes straight off the airport runways and taxiways, prior to discharge into the receiving watercourse. This was installed in the early 2000s, and the whole site covers about 10 hectares in total, of which about 3 hectares are the reed beds, this little cellular system that you can see in the top part of the photograph, and also some aeration tanks. The area, the sort of little wiggly wetlands just to the right-hand side, is designed as a more diverse wetland habitat with public access. And this is just another view of the same site. So this was quite early on. I think it was constructed in about 2002. This was a couple of years after construction. And we used a floating reed bed system there in the distance. And in the foreground you can see wildflower meadows in the public area. What was really nice here was that when we went back for one of our monitoring visits, we recorded reed bunting, which is the first time that particular bird species has been recorded at Heathrow for a great number of years. And it's a really nice example of how you can introduce biodiversity into what's otherwise a very heavily industrialised area. This example is a site called Cringleford in Norwich. And this SuDS scheme was very much led by issues to do with flood management. So this was designed to manage a 1-in-100-year flood event. The basin was originally intended to be sown with pretty boring amenity grass mix, actually. It's a big housing development, multi-phased housing development, and in other parts of the site there were some quite significant areas of habitat loss. So we had hedgerows, some woodland, some semi-natural grassland were going to be lost under the development. So we worked very closely with the local planning authority ecologists to design and agree a SuDS scheme that could also double up as part of the ecological mitigation package. And so we designed a scheme, which you can see on the sort of bottom right-hand side, which incorporates wildflower grassland around the dry slopes of the attenuation basin, woodland planting, marginal planting, and an area of open water. And one of the other sort of key requirements of this particular scheme, which was very much supported, or if not led by the developer, was that if we're going to have this SuDS wetland, let's really make something of it. So it was very much designed as a focal point and a gateway into the development, to give it a sort of positive outlook and create a really good setting for the housing development. And these houses that overlook the SuDS scheme were able to command quite a premium in terms of property value than those properties which were set further back. I think it was something like an additional 10% added to the value of those particular properties. Another nice example of integrating SuDS, this time in terms of public realms. So this little structure here is a cafe, and there's a little sort of outdoor seating area at the far end of the cafe. And it's actually built so it spans over the edge of the SuDS specifically so that people can sit there and admire the open water and the habitats. On this scheme, we have used brick rubble, which you can just about make out under the surface of the water, to absorb phosphates. There was an issue with nutrient levels in the water coming into the system. And it's sort of backfired a little bit because it's worked quite effectively, and the water is so clear that the developer was a bit grumpy because he said it looks as if someone's just come and dumped a load of brick rubble in the pond, and I'm not really very happy about that. But in time it will vegetate over, we've assured him, and it'll be fine. You won't be able to see the bricks. This example is a site called Potterick Carr in Doncaster, and this is another SuDS which is very much driven from a water quality perspective. This site is just on the outskirts of the city of Doncaster, and it receives urban runoff, contaminated with all the sorts of things that Theo's described, and also treated sewage effluent. The wider site that you can see in the aerial here is part of quite an extensive SSSI and Wildlife Trust Reserve, which is managed by the Yorkshire Wildlife Trust. And very much like the Pity Me example, we agreed with the Yorkshire Wildlife Trust that we could incorporate the SuDS scheme into their reserve, provided that we could adequately deal with water quality issues, because they saw this as a really great opportunity to get some additional habitat enhancement, areas of open water, reedbed, etc., into the reserve, which they otherwise wouldn't have been able to do. So we designed a sort of multicellular five big wetland cells into this system, each one supporting areas of reed, and then at the downstream end, so the reed was intended to for water treatment purposes, and then at the downstream end of each cell we went for a much more species diverse planting mix to enhance biodiversity. 2 years after commissioning, and this one was actually constructed 20 years ago now, so 1994, is that right? Just 2 years after commissioning, I won't read it all out because you can read, but we had a huge number of new species which had colonised the area. And the reason why the species diversity is so high is probably because of the location within the neighbouring Wildlife Trust Reserve, but it just highlights how important it is that you've got a source of colonisers, so all of these things need to be able to get there. So it's important, going back to the master planning stage, that you position your SuDS strategically, precisely so that species can colonise from neighbouring areas. This is a more recent picture of... Oh, thank you. This is a more recent picture of Potterick Carr. So the reed's 15 years on, and as I mentioned, the Wildlife Trust are now just beginning to start cyclic management on a 20-year rotation. And this is the more plant species diverse end of the reed beds, showing some nice yellow flag. And the final example is, again, just outside of Doncaster, and this is located upstream of Potterick Carr, the nature reserve. And again, this was all about, well, two things really. This was driven by a management of surface water runoff from a large mixed-use development, but also dealing with pollution from urban runoff as well. And this system was designed around enlarged drainage ditches. And what's quite interesting in this particular design was at the inlet, immediately below the inlet, we designed in a large silt trap. And this was the one that I mentioned earlier, was constructed 8 years ago and is now only a third full actually, and it's still performing well. We incorporated floating reedbed systems into this one because part of the function of this particular SuDS was to attenuate surface flow, so we had quite fluctuating water levels. And there was some concern that during periods of high flow, the reed beds wouldn't function in terms of their water quality treatment function. So the solution was to plant reed beds on floating system, so when the water levels come up, the reed beds also float up, and the mat of roots and rhizomes that hang beneath the floating mat system can continue to improve or treat water quality. 8 years on, it's still functioning exactly as designed. The photo on the left-hand side is a couple of years after it was built, so that's the inlet. The photo on the bottom right-hand side is the outlet structure as it was about this time last year. So we've got significant amount of reed growth and willow growth, and it's just getting to the point we think now where a little bit of rotational management might be a good idea to keep the entrance to the outfall clear. But other than that, it's really pleasing to see that it's a robust system and it's functioning as designed. And finally, I thought I'd just leave you with some suggestions for where you can read more about incorporating biodiversity into SuDS design. So the SuDS manual, I hope, is due soon. I missed the beginning of the presentation, so I'm not sure when that's due. The SuDS Drain website has a number of really good checklists that you can use with some top tips on incorporating biodiversity. And there's a really excellent publication produced by the RSPB and Wildfowl and Wetland Trust, which we refer to quite a lot. It's about a 60-odd page glossy with some really lovely photos and nice case studies and examples. And I think John Day and Bob Bray actually were co-authors of that, they're both in the audience. So I shall leave it there. Thank you very much.
This is Judith from Robert Bray Associates. My question is really at Heathrow. I understand that you were encouraging habitats for birds. Was it a problem at all, the fear of bird strikes?
Yes, it was, yeah.
And how did you deal with that?
Because it was so close to the runway, the Civil Aviation Authority and the airport themselves required us to produce a bird risk hazard management plan. And so we had to think very carefully about the design. So a couple of things we did, for example, were to make sure that the reeds were growing very densely, so that it didn't encourage too many bird species that liked or would land on open water. One of the other requirements was to make sure that the slopes of the system were very steep, so that geese, for example, couldn't come and sit and loaf on the edges of the water bodies. And the airport also frequently comes out and carries out bird scaring activities at particularly sensitive times of year when you've got large numbers of bird species roosting. So there are various sort of mechanisms, both design and ongoing management. Because of the bird strike hazard, the maintenance requirements for that system are much more onerous than they would be on another scheme. But it was a really key consideration.
Right, thank you.
Neil McLean from MWH. Just wondering if you've any concerns or had trouble with pests. I'm thinking in particular with the, let's say, the good guys such as water voles versus rats, which may look the same to the uninitiated, and confusion there and problems, and also maybe dragonflies, which would be the good guys, and mosquitoes would be the bad guys.
It's an interesting question. The simple answer is no. That said, we don't carry out probably enough detailed monitoring to be able to pick up those sorts of problems at that sort of level of detail. So I guess we don't go there to look for those things. So we might go there to look for water vole, but we wouldn't necessarily go there to look for evidence of rat. But to my knowledge, best of my knowledge, it hasn't been a particular issue.
Hi, Owen Hayes from Golder Associates. Is the design for water quality treatment targets and for amenity and biodiversity, are they almost mutually exclusive to a certain extent? Or, if you're designing a reed bed for water quality treatment, does it tie your hands a bit?
No, for the sorts of reasons I showed in, I think it was the Potterick Car example, we managed to incorporate both really because of the way the systems are designed. So you've got these different cells, so you could almost vegetation communities in different cells. So on that one we had reed bed in part of it for water quality treatment. We had more species diverse mix, which has no benefit at all for water quality, but it looks nice. So I think it's just a question of thinking about all these things early on, working as part of this integrated team so that you identify all these potential areas of conflict and finding ways around it. But no, I don't think we've had any particular areas of conflict that we haven't been able to resolve by just working together.